This section covers indirect proofs. These are proofs by means other than working directly from the premises to the conclusion. These types of proofs are based on logical equivalencies that we have previously established. One type of indirect proof is contraposition. One type of indirect proof is contraposition. These proofs use the fact that P then Q is logically equivalent to not Q then not P. So if you can prove not Q, so if you can prove not Q then not P, you have a proof of P then Q. So to start, we assume not Q to be true. And prove not P must follow. We'll do an example. Prove that if n is an integer and 3n plus 2 is odd, then n is odd. So to start with, we assume that n is not odd. That is to say, it is even. So since that's our assumption, we'll say n is equal to 2k. 2k is the definition of an even integer. So this is definition of even integer. Then we'll substitute that value for n into our 3n plus 2. So we'll go 3 then times the substituted value for n, so 3 times 2k plus 2. We'll multiply this out. Now, first let's give our reason for this. This is substitution. Multiply it out, we get 6k plus 2, and then let's just multiply. Scroll this up a little bit, give us some room, and then all we have to do is factor a 2 out, and we get 3k plus 1 in the parentheses. This is simply factor. Notice that on each step I'm giving the justification for being allowed to take that step. Now that I have 2 times 3k plus 1. 3k plus 1 is simply some number. So we have 2 times some number. That means that this is in the format for an even number. Therefore, 2 times 3k plus 1 is not odd. We can say, since not Q, then not P, it follows, oops, scroll back down here again. It follows that P, then Q. So for our strategy here, so far we are expanding definitions we look to see if a direct method is promising, and then we look to see if indirect is promising. And that's our basic set of strategy that we have at this point in time.